Hello, so I thought I would show you a video of how to work these relative velocity problems, and there's kind of a trick to it, and that's I certainly didn't invent this trick, but it's a good trick to use. So, and it starts with really just writing down the velocities and knowing just in a certain notation, and so that the notation that tells you exactly what those velocities are with respect to. Okay, so in other words, like if I want to write down the velocity of the ball with respect to the quarterback is what we don't know, right? We don't know this. We don't know that, but it's defined as the velocity of ball with respect to quarterback. Okay, so the object is first, and what the velocity is with respect to is the second thing. So we just use whatever letters you like, but you have to remember what you're thinking. Okay, well, what other velocities do we have in this? We have the velocity of the ball with respect to Earth, right? They gave us that, and that is velocity of the ball with respect to Earth, right? So ball, Earth, and that is 15.2 meters per second, and it's 25 degrees north of east, right? Okay, and then the other thing we know is we know the velocity of the quarterback with respect to Earth, right? All right, and that, I'm just writing it down here. We'll write down what it is, what they gave us in the second. Velocity of quarterback with respect to Earth. Okay, and that is 2 meters per second west, right? Okay, so this is north, east, west, south. Okay, all right. So now we have all the velocities defined. Now here's the trick. The trick is you want this thing. You don't know this, right? So I'm going to write this down, and we know that we're going to have to add or subtract velocities to get at the relative velocity we want, right? So we know that we're going to be adding or subtracting velocities over here, these two. So which, do we add, do we subtract, right? That can be a little confusing, but there's a trick to it here where you use these letters as your guide. Okay, so I know, I'm going to write this one down first. So I have VBE, that puts B in the first position. And if I write plus VEQ, the Earth with respect to the quarterback, then the quarterback one is in the correct position, the second position of this, right? And these kind of like cancel out. They don't really cancel out, right? This is just a way to remember how to write this stuff down. Now we don't have VEQ, we have VQE, but remember that VEQ is equal to minus VQE. Okay, so it's a good way to remember this stuff. And so I can write this as VBE, which we do know, minus VQE, which we also know. Okay, and now all we have to do is just, make these into their x and y components and add them up, right? So let's do that. So we have VBQ, the x component of that guy, is going to be the x component of this plus the x component of this, right? So we have VBE, the x component of that guy is this thing here. So we have this, so here's our length, so it's 15.2 meters per second. And then times, right, the cosine, because this thing looks like this. This is 25, right? So the cosine of 25 degrees. And then we have minus VQE, right? What is VQE? It's 2 meters per second west. So it's actually negative, right? So negative plus a negative times a negative here is going to be just a positive, and then we have 2 meters per second. And if we work that all out, it's 15.8 meters per second. And then the y direction is this guy here, the y component of this, so that's 15.2 meters per second sine of 25 degrees. And then this guy does not have a y component at all, right? It's just going this way, straight horizontally back. And so that's just 6.42 meters per second. Okay, and so all we have to do now is find the resultant. And of course also the angle. Okay, so let's find the length of our VBQ. That is going to be the square root of VBQ, the x component squared, plus VBQ, the y component. Remember, VBQ is what we want. Okay. All right, so that's just the square root of 15.8 squared plus 6.42 squared, leaving the units out for now. And that's equal to 17.0, whoops, why did I put 7 first? 17.0 meters per second. Okay, cool. And then we want to know the angle that it makes, right? Okay, so remember, if you're looking for the angle, so if you have, you know, VBQ, let's say, here's that, right? We want theta. We know that the tangent of theta is equal to VBQ y over VBQ x, right? The y component over the x component. Sorry, that's BQ x, okay? All right, so that means that theta is just the arctangent of the y component, which is 6.42 over 15.8. That's the x component, and that's equal to 22.1 degrees. Okay, so I hope this helps a little bit. So this kind of thing where you think about getting the indices here that are telling you what the velocity is relative to, it tells you what object has that velocity and what that velocity is relative to in this notation, and it makes it really easy to figure out what you should do, right? And you might have to, you know, do things like use this kind of thing, like we did here. Okay, but this makes it very easy to figure out what you have to add and subtract. All right, hope this helps.